Alright, hello everyone. This is the solution for O Level 2210's previous material for 2022, variant 22, May June. This series will be broken up into three parts. One, this part, which will discuss the task itself. We'll be understanding what the task requires, what the question requires, and how the three tasks will go about accomplishing what we are required to do. The second part will be discussing the pseudocode for task 1, and the third part will be discussing the pseudocodes for tasks 2 and 3. This video series will be recorded with for the solution of pseudocode only. However, there will be um, programming language solutions available in the GitHub linked below. All right, so let's get started with this part. And today we'll be discussing the actual question itself. We'll be looking at what the tasks require and a rudimentary basic understanding of the data structures we'll be using and sort of building up an understanding of how to go about solving the question. All right, so it says that a program is needed to allow a wildlife park to sell tickets. A booking consists of one or more tickets for the same days and can be made up to a week in advance. A booking can be made for a visit of one or two consecutive days. A booking can have extra attractions included, and it will be valid only for the days chosen. So here we now have been given a table for the different types of tickets that are available. So right off the bat, we can see that there are different types of tickets, five of them, and each of those types come in two separate types. So what that means is that we one way of representing this data can be declaring two different arrays, one for the costs for 1 day and one for the costs of 2 days. And each of these will have five different elements. So index 1, 2, 3, 4, and 5. And each of these will be corresponding to these ticket types. So the first index will be the the price for for one adult. So here it would be 20 and here it would be 30 because this represents the 2 day cost, this represents the 1 day cost. So that is one of the methods we can use for implementing this table. And then we can declare a single array for the extra attractions price. So here we have a table that gives us the extra attractions. So we have three elements here. We have the lion feeding, we have the penguin feeding, and we have the evening barbecue. So this array will contain the first element for lion feeding, the second element for penguin feeding, and the third for the evening barbecue. Now it is important to note that in pseudocode we have to declare the type of these arrays as well. So since each of these are real numbers, note that they are not integers since well one they have the 0.00 and even if we could ignore that, for example, 90.00 is the same as 90, right? So here we can ignore that. However, in values like this, 2.50 and 22.50, we can't ignore that. So to accommodate for these values, what we have to do is declare all of these as the type real. Um, and this accounts for the floating points. So this accounts for the decimal points, and now any value stored in these will be stored in this format, allowing for the zero point 0.5 to be accommodated when needed. Right, so now it says that write a program of programs for the wildlife park. Your program programs must include the appropriate prompts for the entry of data, and it must be validated on entry. All outputs, including error messages, need to be set out clearly and understandably, and all variance constants and other identifiers must have meaningful names. We will see all of this being implemented. It might not make a lot of sense right now, but we'll see this being implemented when we actually tackle the code itself. So now here are the three tasks. It says that each task must be fully tested. Um, and task one is to display the ticket options and the extra attractions available. So we have to set it up so that it displays the options, attractions, and prices for 1 day tickets, and then it does the same thing for the 2 day tickets. So if we were looking at how the code might look, so let's say this is your screen. So first it would display all the 1 day options, and then second it would display all the 2 day options, and we would assume that right here or really anywhere in between it would also have the extra attractions. So this would be the extra attractions. Note that the extra attractions do not vary with the 1 or 2 day variation. Per person, it just costs this for every day. So if a person was buying this for 2 days, so it would be this times two, because one person is 2.5, and if the person is there for 2 days and every single day he or she goes to line feeding, that automatically bumps that up to twice that value, right? All right, so that is this, and then it also shows the number of days available for booking. So assume that there are tickets available for any valid day. So any valid day would be Monday through to Sunday, right? Those are the only days that exist. So Monday, Tuesday, Wednesday, Thursday, and Friday, Saturday and Sunday. So that would also be displayed either at the bottom or at the top. It doesn't really matter because all of these are being done in one task, regardless. So to recap, task one basically just gives the user all the relevant data. So it gives you the number of days. It displays the number of days. It displays the prices for 1 day. It displays the prices for 2 days, and then it also displays the extra attractions prices. Let's just call this EA for extra attractions. So this, and let's assume that this is our screen. So this is what task one would look like. This is what it's doing. This is what we are supposed to accomplish out of task one. It's just the setting up of the menu essentially, just displaying the options available, not really doing much, not really taking an input. It's just showing us the options that are available. So here's where it gets interesting. Now, task two is to process a booking. Now, here what we're going to do is that we're going to input the tickets and the extra attractions required, and then calculate the total cost of the booking. So, um, we have all of these different types of tickets. So we have adult tickets, child tickets, senior tickets, family tickets. Family tickets consist of two adults or seniors. So it's not two adults and seniors, or like it's not that we can have two of these or two of these. We have to have like both of these have to combine to two. So it can be one adult, two seniors, two adults, zero seniors, zero adults, two seniors. And also it says up to, so they don't have to these don't have to sum up to two. They can also be just one adult and zero seniors. But as we'll see, that's not the most efficient ticket to purchase, which is what we will also be calculating in this pre-release material solution. So we're supposed to input all the tickets required. So notice that it says tickets and not tickets. So we will be running the input for every single value, just in case the person may want to input like two adults and one child and maybe one senior, or they would just go for the family ticket. It's really up to the user, and as developers, we shouldn't really constrict the options available to them, right? So we will display all of these, and for every single type, the person will have the opportunity to input the number of tickets they want to buy. And if they don't want to buy any, so they can just skip them. So for example, if someone doesn't want to buy an adult ticket, only wants to buy a child ticket, so when we ask them to output the adult ticket, they can just ignore that, and instead they can input sorry they can just ignore that, and instead they can just enter one child ticket and one senior ticket or whatever they require, right? So we will be showing them all the options. It is up to them whether they wish to purchase it or not. All right. So once we've done that for tickets, we'll do the same thing for extra attractions. So just ask them how much of each attraction they want, and so forth and so on until we have all the required inputs. And then we're also going to be calculating the total cost of the booking. So just to build up a sort of intuition of how we might accomplish this task. So every time that they purchase a ticket, we'll just have some variable, let's call it total, and this variable will be storing all of the prices so far. So let's say I select 1 day, one child, right? So the $12 that's stored here. So this would have 12.00. This would then get added to this total. So it would become total equals total plus 12, right? And so forth and so on until you have all the values added. And of course, we'll see how this is actually implemented in the code. This is just for you to get an idea of what we're supposed to be doing. So then it also allocates a unique booking number. Now this is important because every time we run this loop, every time that this task is run, it's going to implement this booking number. So this sort of gives us an idea of the structure of the code that we require. So for example, if it was just one block of code running once, so like we input all the tickets and then we calculate the price and we do these tasks and then it ends here, this this unique booking number, we would have no way of really updating that, right? Because every time we initiate this block, let's say booking ID equals 0 right at the top, right? We're initiating it. So if this was the code that was being run, and it was not looped, that would mean that every time we start this code, it would instantiate this to 0, right? So this variable would become 0. So this gives us an idea that our code is supposed to be run in a loop. The first value of the ID is set here, and then every time we run this loop, it is going to increment the ID by one, right? Don't worry if this doesn't make a lot of sense right now. This was a very abstract understanding, and we'll of course go into the detailed code of this when we run it. So don't worry if that doesn't make sense. This is just an overview. We will be doing the actual code in the next sections, the next two videos. So we have to allocate a unique booking number. Then what we have to do is display the booking details, including the total cost and the unique booking number. So like I said, this unique booking number will be referenced, and then we'll also have the booking details. So whichever of the tickets the person purchased, we'll display that. We'll display that, okay, these are the tickets that the person has purchased, and we'll also be displaying their total cost. And there we go. This is the part I was talking about. Repeat as required. So this entire process of displaying and then booking your tickets, this will be repeated for as many times as required. So basically, we'll have a check in the end that do you want to continue? Let's say it's the end of the day, right? And the park is closing down, so no more tickets will be bought at the end of the day, right? So then the person can just enter no, I do not wish to continue, and then this entire thing would break, right? It would come out of the loop, and the code would be finished. So that is what we require of task 2. And again, if the loop thing didn't make sense, don't worry about it right now. This was just an overview. We'll be going into the code in the next video. Um, or I mean, for task 2 and 3, we'll be going in the video after the next. So task 3, we have to. It's basically just an add-on task. It is ensuring that each booking is the best value. Now this is where things will get interesting. We have to check that the total for each booking gives the best value and offers an alternative if this is not the case. So what does it mean if something has the best value, right? So for example, buying two family tickets is better than a group ticket for a group of 10 that includes 4 adults and 6 children. So let's break down what this means, right? And again, we'll be going into the code of this in a later video. Right now, we just need to understand how this checking will be done, how to actually go about this. What does this even mean, right? So here it says that now we have two sort of group tickets, right? These are individual tickets, so this is per person. Here we have sort of grouped tickets. So this family ticket is a grouped ticket. Notice I'm not saying group, I'm saying grouped, which like as in like more than one, right? So we have more than one person in each ticket. The family ticket has two of either of these types and then three of children, and then the group of six or more is $15 per person. Now, notice that this is per person. It does not care whether this person is an adult, a child, or a senior. It will just price them $15 per person. Now, the reason that this ticket type exists is that when you're purchasing for let's say you have a group of 4 adults and three children, right? So that would bring a total up to 7. So for that, the ticket price would become four times this, so that would be 80, and then three of these, and that would be more than if we priced $15 per person, because notice that this $15 is indeed more than the child value, but it is less than the senior value and less than the adult value. So if we purchase this group, if we purchase this ticket type, the price per person on an average goes down. It goes down because it goes down for the adult, and it goes down because it goes down for the senior. Yes, it goes up for the child, but that is a compromise that is still efficient. It's cost efficient because it is still decreasing the values for these two, right? So if an adult was purchasing, if an adult was purchasing their ticket in the group section, it would still cost them less because it brought it down from 20 to 50, right? This is per person. So regardless if the person is an adult, a child, or whatever, like they will still be priced 50, right? So that brings the value down for the adult. So that is why that is an efficient, cost effective method of purchasing tickets, right? So let me just clear this out a bit. Here we go. So that's the group ticket. However, if you notice that the group ticket, so let's say we have let's say we have two adults and three children, right? So that would be a condition that is suitable for the family ticket. So let's see what happens if we try to buy that with either this or with this. Actually, group of six or more people. So let's just say we have three adults and three children, right? So if we have three adults and we have three children, so that would mean three of these and three of these. So three of these would be 60, and then three of these would be 36. So that brings the total up to $96, right? Um, However, if we take into account this, so that would mean that we have a total of six people, right? So six people, and we have $15 per person, so that brings it up to six times 15, which brings it to 90, I believe, if that is correct. Yes. So that brings it up to 90. Notice that this family ticket is only has an offset by $6, right? So if we brought this up twice, that would be still more cost effective. Like it says here, that buying two family tickets, group that includes four adults and six children, that is still more cost effective than buying two of these tickets. And that is because that we're not sure how many children would be a part of the would be a part of a large group, right, like this, right? And it because of how they're priced, it might turn out that the group ticket overprices some of the members, such as the family or such as the child or senior. Instead, what we want to do is that if it satisfies this condition, that it is any multiple of two adults and seniors and any multiple of three children. So, for example, here we have four adults and six children, right? So, four is a multiple of two, and six is also a multiple of three. So, four divided by two is an integer, right? We have some integer value. We don't have any remainder. There is no remainder. So it means that it is a multiple. And similarly, six is a multiple of three because there is no remainder when you divide six by three. So if this condition is satisfied, that means that the right ticket, the best ticket to buy, is the family ticket. Otherwise, the best ticket to buy, if there are six or more people, the best ticket to buy is the group ticket. However, if there are not more than six people present, or there so if this condition that the adult plus senior and the children are a multiple of this factor, or they're so if this is false, or sorry, if this is false and this is false, that there are not more than six people, then the right tickets to purchase would be the individual tickets, because these are then the best price. So when we're going about implementing this task, making sure that every ticket is the right one to purchase, we have to basically look out for two things. One, we have to look out for, are there more than six people, six or more people? If there are, then this ticket is the best to buy. However, if those people sum up to if in that group of people the sum of the adults and seniors is a multiple of 2, and the number of children is a multiple of 3, so if this is true, then the best ticket to buy is the family ticket. So these are the two factors that we're looking for. If both of these conditions fail, then the best tickets to buy are the individual tickets. And so this is how we'll be monitoring, and we'll be deciding whether or not the tickets that are purchased are the right tickets. So that is a lot. That is quite the mouthful. If you didn't keep up with a lot of that, it's all right. You can watch this again, or you can just watch the part where we get into the code of this, and it'll make a bit more sense then. But this is what this task requires of us. This is what we'll be doing in this period material. Again, this is May June 2022, paper 2022. Yeah, sorry, paper 22, and these are the three tasks. So by now, hopefully, you have sort of some level of understanding of what some basic understanding of what we're supposed to be doing in this pre-release material. In this question paper, I don't know why I keep saying that. In this question, what we're supposed to be doing. And if the way we're gonna do it doesn't make sense right now, again, just don't worry about it. We'll be when we are looking into the code of it, it'll make a lot more sense then. So yeah, that's it for this one. This was an overview of the question, and in the next video, we'll be starting with the pseudocode for task one. So I'll see you then.